Understanding errors is very important for building strong JavaScript applications. They help us find the problems in our code, deal with unusual situations smoothly, and fix bugs effectively. Here's an example of a common JavaScript error. In this code, we have a function called divide that takes two inputs, a and b. Inside the function, there's a check to see if b is equal to 0. If it is, we throw a new error with the message, division by 0. This means the code will stop and show an error because dividing by 0 is not allowed. Let's explore some common types of errors you might encounter in JavaScript. First, we have syntax error. This error happens when the structure of your code is not correct, like when you're missing a closing bracket. Next is the type error. This occurs when you try to do something that's not allowed with a certain type of data, like trying to use an undefined value as a function. Then, there's reference error, which happens when you try to use a variable that hasn't been declared. Finally, we have range error. This occurs when a value goes beyond the allowed limit, like trying to create an array with a negative length. The try-catch block is JavaScript's way of handling errors. It allows you to deal with potential problems in your code, prevent your application from crashing, get details about errors, and continue running your code even if an error happens. Here is the basic syntax of a try-catch block. First, the try block contains the code that might cause an error. For example, if we try to parse an invalid JSON string, it will throw an error. If an error occurs, the catch block will execute. It receives the error object, and you can use this to handle the error. For example, you can log the error message. The finally block in JavaScript is used to run code that should always execute no matter what happens in the try or catch blocks. This block is useful for cleanup tasks, like closing database connections, releasing resources, resetting states, and logging completion of operations. For example, imagine you are working with a database. In the try block, you open a connection and perform a query. If anything goes wrong, the catch block handles the error. Regardless of an error or success, the finally block makes sure that the database connection is always closed. This ensures resources are freed up correctly. You can also create and throw your own custom errors in JavaScript. This is really useful for adding details and context to the errors that might happen in your code. When throwing errors, use descriptive messages that explain clearly what went wrong. Include details that can help in debugging, like where did the error occur, and what inputs caused the issue. Throw errors early in your code and catch them only where you can handle them properly. Also, use the right type of error for the specific issue, like error, type error, or range error, so you can easily identify the type of problem. For example, if we look at the code, the function validate user checks if the user object, username, and age are valid. If any of these conditions fail, it throws an error with a specific message and the type of error. You can create custom error classes to handle specific error situations in your code. This is really helpful when you need more control over the error object. To create a custom error class, first, define a class that extends the built-in error class. In the constructor, you can set the name of the error, provide a message, and add other information specific to your error. It is important to call super with the error message so it is stored properly. Also, use error.captureStackTrace so that you get the correct error stack trace. You can also add a toJSON method so that you can serialize the error information when needed. Looking at the diagram, we see the validation error class, which inherits from the base error class. The validation error has its own specific properties like field, and also provides a way to convert the error to JSON object. Error propagation is how errors travel through your code until they are handled. When an error happens in a function, that function might throw the error, and that error is then caught in a parent function. Each function in the chain may decide to add more context to the error or just pass the error upwards. In this way, an error can travel through multiple function calls until it is handled at some level. For example, the function handleRequest calls processData, and processData, in turn, calls validateInput. If an error happens in validateInput, it will travel to processData. which adds more information to the error and throws the error again. Finally, the error reaches the handle request function where the error is handled. This pattern of error traveling through the function calls is called error propagation. Handling errors with asynchronous operations like promises is crucial to build robust applications. You can use the .catch method to handle any errors that occur when working with promises. When you have a chain of promises, you can use a single .catch block at the end to catch errors from any of the promises. If you use promise.all, it will stop if any of the promises fail. In such situations, you can use promise.allSettled, which will give you the results of all the promises whether they succeeded or failed. To make your code more organized, always return a promise, and be sure to handle errors. Use the finally block for any cleanup tasks you need. Also, always return a promise so you can continue to chain promises. Async/await provides an easier way to handle asynchronous operations and their errors. When using async and await, you should always use try and catch block to handle errors. Inside the try block, you can fetch data from an API, and if the response was not okay, then you can throw an error. Then you can catch specific errors based on their type. For example, you can treat network errors differently from other errors. When using async and await, it's good to have proper error handling. Always use try-catch. Check for HTTP errors and handle them properly. Also, you should try to catch different types of errors and handle them appropriately. When an error occurs, you may also add more context to it before rethrowing the error. Some of the pitfalls to avoid are forgetting to use await, not handling all error types, missing try-catch blocks, and swallowing errors silently. Debugging is an important aspect of software development. Use tools such as browser DevTools to debug your code. The Sources panel in the DevTools allows you to set breakpoints and step through your code. The console helps in displaying error messages, and the Network tab lets you monitor network requests and responses. You should also use error monitoring services such as Sentry and Rollbar. These help in tracking errors, logging them, and also setting up error notifications and alerts. When debugging, use console methods like log, dir, and table to see the values of variables. Use the debugger statement to set breakpoints. Also, you can use console.trace to get the current stack trace. Following these tips and using the right tools will help you fix errors in an efficient way. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.